Yep, it's powering up time. Welcome to Ralph's house.
Welcome to Ralph's house!
Yeah, I'm sure you've all been hanging in, waiting to see me power this thing up. Well, I'm going to err on the side of safety. That's what I'm going to do, because I need to check the voltages on this thing, so I have a rough idea what the transformer puts out raw. And you never know, the selenium rectifier may work. We may be able to get some voltages off that as well. So what I've got to do is I've got to snip all these wires, remove the primary side. I shall solder a mains lead on that side with a fuse, and mark them all up. And the way I'm going to do it is this. Can you see that? I've got 3 dots, a space and 3 dots. I'm going to cut right between those two. That way I know where all the wires go, because these aren't quite so easy to deal with because they're braided. It's not like, you know, modern PVC where you can just strip the outer sheathing off. This is just a bit tougher actually. But I thought that's what I'll do, and I'll get this transformer on the bench and see what it puts out. And I'll also, certainly on the DC side, get the orientation right, which is positive and which is negative. I need to get that right, and then I can get my 12-volt power supply on it and see what happens. I've definitely got to, before I do that, is check all the bumpers on the playfield and make sure none of them are shorted. Otherwise, when I plug it in, it's not going to go bang, but it'll buzz about and all the solenoids will go berserk. I really want everything disconnected so I can test each bumper in turn and see how it all works. I'm not going to be able to score anything, unfortunately, because I'll be disconnecting the bulb side of it, but I'll do those bit by bit. The main thing is to get this thing powered up and make sure it actually functions. So that's what we're going to do. Let's snip that out first and put a meter on it. This is my go-to meter for jobs like this. I think it's Chinese actually. Yeah, can you read that? Aneng, but it's 618A. If you look for that on eBay, you'll find it. I think it's under 15 quid. But what I like about this one is it'll handle anything up to 600 volts, and it doesn't care whether you connect it to DC or AC. It will automatically change. There's one at work I can use, which costs a darn sight more than this one, which does the same thing up to 600 volts. But I like this little meter. It's very good. And those that have seen it have said, "When did you get that?" That's where I got it. You probably get it on AliExpress anyway. That's what it is, 618A. If you look for that, you'll find it. Right, let's get that cut out. Right, there she is. She's out with the selenium rectifier. This rectifier was mounted on a metal bracket, actually, which is still in the machine. You just had to unbolt it. 3 possible tap-ins. 200, I think, 220 and 240. Well, it was on the right ones. I didn't need to mark those two because it's AC, so it doesn't matter which way around you got it. But I was hoping that through the selenium rectifier I can at least work out the positive and the negative for the 18 volts. So that's why I've got it out on the bench. So next thing is to solder on a mains lead to it, and we'll start doing some tests. My guess is, and that was before I even took it out, that these 2 wires are for the, well, rumour has it again, that it's 18 volt. They're thicker cables. I would imagine that's correct. And also because they're running through the selenium rectifier, because it wants 18 volt DC, allegedly. I'm going to see if I can run it on 12. But I've got an 18 volt supply if I need it. And the bottom 2 wires, they'll be for the 6 volt AC, but they're sort of immaterial really, because I'll be wiring the bulbs from scratch firstly, because I'm going to be fitting LED bulbs for those. I'll be a bit time consuming, but as I say, the light from the LEDs was identical to the ones from the bulbs. I did extensively test those, and they'll last a lot longer. So that's why I'm switching over to LEDs. I don't think it'll do any harm at all. So right, let's get that connected. I'm going to have a bit of respect here, aren't I? Hopefully you can see that meter. So we've got $242 showing on there. That seems about right. On this side, these are the thicker cables. That's interesting, really. This is, all right, 16.27 AC. Right. So these two are going through the rectifier. So let's see what we've got then. 13, 14 volts, 14.12 volts DC. And if I reverse those, try and get a good connection. Yeah, 14.13, good enough. But then that's minus. So that cable is the positive one. It's the colour's gone a bit now, but it is reddish. So we know that that is the positive for the main board, and it's 14 volt DC. My guess is 12 volt power supply will do it. I think the 18's asking a bit much, isn't it, really? So that means I've then got these two to test. This should be AC because it's not going through the rectifier. It's not easy to get a connection either. Let's see what we get. Come on, give me a connection. It's saying 10.7. Is that right? Is it just not? Yeah, 9.7, 9.8. Let's try it that way around, see if there's any difference. .6, am I right? 7.48. Well, that's definitely for the bulbs, and that's the AC side. There's going to be a bit of variation in it. So we now know that is for the bulb side, which I won't be using anyway, because I'm going to use 12 volt DC, so they're redundant. I might as well take those up on there. But we know this transformer works. And as far as these concerned, that's the negative to the pinball, and that's the positive, running about 14 volts. There we go. That's how you test a transformer. So what have we learnt? Quite a bit, actually, because I had no idea which was the positive and negative on the playfield, and I know that now. This wire is the positive to the playfield, that's the negative, and at the moment they're the only things I need to worry about, because the bulb circuit has no power to it. As we know, it's not connected to the transformer anymore, so theoretically I should be able to get power to that. How exciting is that? But am I going to do it in this episode? No. This is going to be powering up part 1. In part 2 we'll actually put power to this, and I've got 3 power supplies. I've got a 12 volt, they're all switched power supplies. I've got a 12 volt one, an 18 volt one, and I've got a 24 volt one. They are adjustable, so my thinking is I will try in the next one, take the 18 volt power supply, adjust it down and see if it will come close to 14 volts. May only get to 15 volts, but I think that'll be okay. There's not a lot in it. It's either that or wind up the 12 volt one to 14 volt. So we've learnt quite a bit, I think. The selenium rectifier did still work, amazingly. And you're thinking, well, why didn't you use that? Well, you know, I've said before, I'd rather have a switch power supply in it, something a little bit on the safer side. As I say, I'm upgrading the bulbs to LED so that they'll run on 12 volt. So we will see in the next one how we get on. One of the things I've got to do is I've got to clean up all these leaf switch contacts. You know, they're like points in an old car. They'll be very corroded by now. And although, you know, it hasn't been stored anywhere damp by the look of it, it hasn't been in use in a lot of years. That's fairly evident by things I've already had to clean up. So, yeah, I've got to go around, check all these joints. I'm not going to bore you with all the soldering and, you know, redoing the wires. I have got a mystery wire, and I still don't know where this goes. There didn't seem to be anything it was connected to. Yeah, I don't know what to do about that one, because it's also, I think I mentioned in a previous one, when it goes round the back it gets a little bit suspect because, you know, a lot of this braiding on it is just disintegrated, and people, looks like they've tried to patch it in the past. I don't know why people bother doing that. Why didn't you just put a new wire in it, you know? Oh well, maybe it was just to get it going. Quick bodge, as they say. Right, so I'll see you in the next one, and we'll get the power applied to this, and we'll see what works. I will just get on top of the playfield though, and check that none of these are in contact, because I think I explained these. They've got a little loop and they make contact, and I don't want all the solenoids going off when I put power to it, so I'll make sure they're all separate. Not worried about the bulbs because the bulbs aren't connected. What we want to see is that these actually work, and we tap them and the solenoids start to work, see what is working and what isn't working. That'd be a good start, wouldn't it? Anyway, thanks for watching. Oh, and don't forget to subscribe.